The primary role of an operations manager is to improve productivity. So productivity is where we're tracking performance over time and we're looking at our outputs, what we make, versus our inputs, what we're using to make them. And so as we look at increasing productivity, there really are two key ways to increase productivity. Either there is a change in your process, so you are going to do things differently, which is why we look at process design in the previous level, or there's some kind of change in technology. So if we're changing our level of automation, that would change productivity. So really sustained increases in productivity come from changing your process, how you make your good or service, or in the level of technology that you're using. Maybe you found a new way to make your good or service, or maybe that means automation. So let's look at how we measure productivity. We take outputs divided by inputs. If we are measuring total measures of productivity, it is all outputs divided by all inputs. Now, there are other measures of productivity, like multi-factor measures of productivity, in which case we are still looking at the output, but the inputs are just a subset of the total inputs. So for example, you can have a multi-factor measure of productivity where the inputs are just labor and machines or capital. You could have a multi-factor measure of productivity where the inputs are labor, capital, and your energy or utility usage. So we can measure productivity in different ways, as a total measure of productivity or as a multi-factor measure of productivity. And there are also partial measures of productivity. That is, we could look at what we're getting out of just our workers, so output divided by labor. We could look at our machine productivity, what are we getting out of our capital. We could look at material productivity, what are we getting out of our resources that we're using. You can look at energy productivity, what are you getting out of your utility usage. So there can be partial measures, multi-factor measures, and total measures. In which case it's outputs divided by inputs. So let's take a look at some productivity measures. And let's go online to Statistics Canada. And here you see how it says multi-factor productivity measure. So if we actually go, see how it has a little 2 there, if we go down to the bottom of this list, we can see what is included in our multi-factor productivity measure. So notice it says the multi-factor productivity measure, in which all inputs are used in production, is the ratio of real GDP, so that's our output, the value of what we produce, to combined labor and capital. So this multi-factor measure used by Statistics Canada is your output, so the value of what you make, divided by labor plus capital or machines. Let's go back to those numbers. When we look at that multi-factor measure, we can look at the business sector, for example, or we can look at, we can break that down into making goods, making services. We can break the goods down into durable goods, that's long-lasting things like cars, electronics, furniture. And we can look at non-durable, which is primarily food. We can also divide it even further down, and we can look at different industries. So if I go to the add remove data, I can look at specific industries. So let's look at oil, and let's look at manufacturing. Okay. We can see here for oil that in 2015, there's a productivity measure of 76.51. So that's $76.52 per unit. And here they're adding together labor and capital. And so when you add together inputs that are multi-factor inputs, it doesn't make sense to add one person and one machine together. So when you do multi-factor measures, those inputs that are added together are in dollars. So this is $76.52 worth of goods created for every dollar of combined labor and capital. If we look at 2014, that number is 78.075. We look at manufacturing. For 2015, it's 104.989, and for 2014, it's 105.741. If we have productivity measures for multiple years, we can determine whether the productivity is increasing or decreasing. So let's go back to our slides. And we can measure productivity growth essentially by taking the new number, so new, minus old, divided by old, and then we multiply times 100 to turn it into a percentage. So let's actually do this calculation for manufacturing and for oil. All right, so what we found is for oil, the numbers were 78,075 and 76,519. So to find our productivity growth, remember it's new minus old divided by old times 100. So we take 76.519 minus 78.075 and divide it by the old number, which is 78.075, and multiply the whole thing times 100. When we do that, we find that for oil, the productivity has actually decreased almost 2% in those 2 years. So from 2014 to 2015, productivity in the oil industry declined by 2%. We could do the same thing for manufacturing. In manufacturing, we had 105,741 in 2014 and 104,989 in 2015. So to find our productivity growth, it's new minus old divided by old times 100. So it's 104,989 minus 105,741 divided by 105,741 times 100. And we notice again, the newer number is actually smaller than the older number, which means we have a decrease in productivity. And for manufacturing, that decrease in productivity is just under 1% at negative 0.71%. So for manufacturing and for oil, productivity declined from 2014 to 2015. So let's go back to that website. And notice that all these multi-factor productivity measures from 2014 to 2015 show a decline in productivity, except for one. Notice that the non-durable manufacturing goes from 103,729 to 104,911. So the only area that really saw an increase in productivity from 2014 to 2015 was in food production. Now let's go back to our slides here. So in this case, we were looking at productivity growth when we already had a productivity measure. And the productivity measure we were using was not a total measure of productivity, it was a multi-factor measure of productivity. Whenever you measure productivity, there's some decisions you have to make. How are you going to measure output? Are you going to measure output in terms of dollars, or are you going to measure output in terms of units produced? Then you need to decide what your inputs are. Will you use all of the inputs, in which case you're doing a total measure? Or are you doing just some of the measures, in which case you have a multi-factor measure? If you are doing multi-factor or total, then your inputs you need to measure in dollars, because it doesn't make sense to add a unit of labor to a unit of energy to a unit of a machine. If, on the other hand, you are looking at a partial measure of productivity, then you can decide whether your input is measured in dollars or if it's measured in some kind of unit. So when we look at partial measures of productivity, it's output. divided by a single input. For example, this is labor productivity. Output divided by labor. It can be measured in different ways. We can measure the number of units produced per labor hour, so per hour worked by one person. We can look at the units of output per shift. We can look at the value added per labor hour, so not just what they produced, but how much extra value there is, so what we're selling it for minus the cost. Or we could look at the dollar value of the output per labor hour. So typically, you're looking at the dollar value of output per labor hour or units of output per labor hour. These are the most common measures of productivity. And of all the partial measures of productivity, labor productivity is the most common. But you can also look at how well you are utilizing your machines by looking at the output per machine or per dollar spent on the machine, per machine hour. You can look at how well you're utilizing your raw materials, so material productivity. You can look at energy, units of output per kilowatt hour, for example. So there are different measures of productivity, and you use them depending on what you are trying to improve as the operations manager. If you're trying to improve your workforce, you might focus on labor productivity. If you're trying to decide if you should buy additional equipment or fix the old or change the way that you are making your product, you might look at machine productivity or material productivity. If you want to have a bigger overall measure of how the company is doing, you might use a multi-factor or a total measure. Statistics Canada uses the multi-factor measure because they're trying to get an idea at a bigger picture look of how overall companies are doing in terms of the amount they're producing compared to what they're using to make it. And since each company is using different things to make their goods, that's why they're using these multi-factor measures. Well, let's look at Canadian productivity. Canadian productivity has actually been very flat over the decades. The typical worker in international dollars, so this allows us to compare between countries. It's not a real currency, it's kind of a bundle of multiple currencies. The typical worker in Canada makes about $76,000 worth of goods. If you compare this, the typical worker gets paid about $45,000. So we make more in goods than we make in pay. But in terms of the increase in productivity, we haven't seen a whole lot of increase in productivity over the years. From 2014 to 2015, we saw it was negative, but most of the time, even when it's positive, it's pretty small. When we compare productivity across countries, Canada is less productive than the US. Canada is more productive than China. We're less productive than the US because we use less capital, less mechanization. When you use more capital, more machines, then that means that for each individual worker, if we're looking at labor productivity, which is what we see here, then that means each worker is contributing more because they might be looking over multiple machines that are doing more work. You don't need as many workers, so each worker is now adding more. So Canada uses less mechanization than the US, which is why we have less value added, and so a lower productivity number. For countries like China, that use a lot more manual production, then each worker contributes less to the total product, and so the productivity per worker is lower. The other thing that we see is that countries that produce finished goods are adding more value to what they produce, and so the productivity per worker is higher. In countries that may mostly harvest raw materials and then sell those raw materials, there's less value added, so there's less productivity per worker. In this case, you can see the US here, and we can see Canada right here. Okay. So we're about the OECD average, so the average of competitive economies. When we look at productivity growth, we said the way to get sustained productivity growth is you either needed to change the process or you need to change the technology. So when we look at this, we need to consider how that change is coming about. And the key is the level of conceptual learning and the level of operational learning. When we talk about conceptual learning, we're talking about understanding cause and effect. So you have an issue and you know why it's happening. So in order to create sustainable improvements, we need to be able to fix issues, become more productive, but we need to know why. Why is this happening? Why are we seeing what we're seeing? Then we also need what's called operational learning. This is where we can implement a theory with positive effects. So we see an issue, and in this case, we know how to fix it. So the previous conceptual learning was why was the problem happening? Operational learning says, well, now we know how to address it, what to do about it. In order to have sustainable increases in productivity, you need both conceptual learning and operational learning. You need to know why, and you need to know how. Let's look at these scenarios where your operational learning might be low or high, and your conceptual learning might be low or high. So let's start first with this firefighting. So you are firefighting if you solve the problem at hand. So you're putting out fires. So when you do firefighting, usually to address it, you're going to come up with some better training for your employees. So you tell your employees, hey, we have this defective product. We need to figure out how to improve it and keep an eye out for defects. So let's say you're Apple and you're producing iPhones and there's an issue on the phone with discoloration. We saw some discoloration on the iPhone 7 screens when they came out. Now, the firefighting approach says there's discolorations on some of the screens. Employees keep an eye out for defective product. Well, the challenge with this is that after a while, your employees, they forget to be on the lookout for certain things. So firefighting really has no impact long term. We're going to look out for the defects and problems now, but over time we kind of go back to the way things used to be and forget about it. So it doesn't have a long-term impact. So let's look at artisan skill. Okay, in artisan skill, we know how, because the operational learning is high, we know how, but not why. So we have more defective iPhones coming down the assembly line, and we're seeing that on humid days, so phones made on humid days have discolorations on the screen. Okay, so discolored screens. So we know how the problem is being created. It's caused on humid days. But we don't know why it's happening. We don't know why humid days are causing discolorations on the screen. So this creates a challenge in terms of creating lasting change, because if we know how the problem is created, humidity, but not why the problem is created, we don't have a way to fix it and prevent it in the future. We can try to make it less humid in our factory, but we don't really know why that humidity is impacting the quality of it. So we're going to continue to have defects whenever we can't control the humidity level. So again, not sustainable change. If your operational learning is low and your conceptual learning is high, you have what is called an unvalidated theory. This is where your research and development department creates a whole new way to create an iPhone. And this iPhone is so much better, it's not going to have any of these defects. It's a much better product. But what they want to make is so time-consuming and delicate that it would be so expensive and the quantity we produce would be so small. So in theory, it's a much better product, but the problem is we can't go for it on a big scale. It's not scalable. Okay, so they can make a product that addresses the issue, which means we have high conceptual learning. We know why things are happening, but the operational learning is low, and so the solution they're giving us is not something we can implement big scale. So really, the only productivity or long-term productivity comes from when we have operationally validated theory. We know why something is happening, we know how it's happening, only then can we address both, and we can then create a better product, more of a product. So increases in productivity come from changes in how we do things and changes in technology when we know how and when we know why. When our operational learning is high and our conceptual learning is high, or we have what is called operationally validated theory. Now that we have looked at how productivity is measured, how productivity growth is measured, and how we can get productivity through a change in process or technology where we know how and why things are happening, let's do just a couple of practice problems. So let's suppose that you have a factory that makes canned peaches. And so you make 400. Change that to a black pen. That's it. All right, you make 400 canned peaches. You have 4 workers, and each worker working half an hour each can make the 4 canned peaches. So we can measure productivity. In this case, we can measure labor productivity, and we always need to specify what we're measuring it in. So this is labor productivity, and this is going to be in units per labor hour. So to find units per labor hour, we're going to take our 400 canned peaches, and we're going to divide by our 4 workers, each working half an hour each. So 4 workers working half an hour each is equivalent to 2 hours by 1 worker. So if we take that 400 divided by 2, we end up with 200 units, in this case our canned peaches, per hour of labor. So productivity, you always have to specify what are you measuring it in. And this is saying for every hour worked by a person, they're making 200 units of canned peaches. Well, let's look at a different example. All right, let's suppose that you have a company that makes paper towels. All right, at our company, we have labor costs of 160. We have material costs of 50. We have overhead of 320. And we produce 2,000 rolls of paper towels per day. So how could we measure productivity? Well, one option is to look at labor productivity. Labor productivity we can measure in terms of units per dollar of labor, in which case we'll take our 2,000 rolls per day and divide it by the $160 we're spending on labor. And when we do that, we find that we have 12.5 rolls per dollar of salary. Now the key with labor productivity, or any productivity measure, is it's all about comparison. Either comparing it over time or comparing it to another company or some kind of benchmark. So this single calculation alone wouldn't be good enough. We would need to compare it to something else measured in the same units. So we could either compare how we did the previous day or the previous year to this, or we could compare to another company or another location and how they were doing. So we need something to compare it to. But since we're doing these calculations, let's look at how we would calculate a multi-factor measure of productivity. So for our multi-factor, we still have our output on top. So here we have our 200 rolls per day. And then we divide that by our inputs. And so let's do labor and what do we have? Materials. So let's do our 160 plus 50. And when we do that, we get 200 divided by 210. Oops, sorry, 2,000 divided by 210. And you end up with 9.55. Well, what is that, 9.55? It's 9.55 rolls per dollar of labor and materials. Remember, if you're doing multi-factor, then the inputs need to be in dollars, since it doesn't make sense to add a worker, in this case, plus some materials. We can also do a total productivity measure. And when you do a total productivity measure, it's all of the inputs. So still we have our outputs on top. That can be a number of units like this example, or it can be in dollar value like we saw with the Stats Canada stuff. So 2,000 divided by the 160 from labor plus the 50 plus materials plus the 320 for overhead. When you do that, we get 3.77, and we always need to specify what is that. It's 3.77 rolls per dollar of inputs. So always specify what you are measuring your productivity in, and they need to compare it to something, a previous year or a different location.